Hi everyone, my name is Anvita Bansal and we are back with another lecture based on strings from our SDE sheet. So the problem that we are going to discuss today will be longest prefix suffix. So let's move to the problem and understand it. Okay, let me check if you guys are able to see my screen. Fine. Okay. So you are given, let's have a look here. Let me check. Okay, you are given a string like this, okay, and you need to find the length of the longest proper prefix which is also a proper suffix. Now what does that mean? See, prefix and suffix can be overlapping, but they should not be equal to the entire string. Let's take an example and understand. So this is the test case that I will be discussing, but before moving to that, let's understand what is a prefix and a suffix. Let's say we have a b d a b. Okay, so prefix, as you all know, prefix should be a substring which starts from 0th index, and suffix should be that substring of the given string whose ending index is the last index of your given string. If these both are equal and can be found in the same string, that means you need to return such length of the longest prefix suffix. So what example they have given you? It's AB. So what is the length of longest prefix which is also suffix in this string? So if you check single character A, okay, then this is single character A. This character B, this character B. If you see, AB can be found as AB in the end of your string. So this can act as a prefix as well as a suffix, and this is the only prefix suffix that you are getting. So the length of it is a length of that prefix or suffix, since both of them are equal and same, so we return length as 2. Okay, if I talk about this a, 4 times a is given. Now what is the longest prefix suffix that you can get? See, they have said that you can find the overlapping characters also, but how do you find that to be a longest prefix suffix? Let's see. So if you take in this string, if you take this as your substring, you can definitely get, if this is your prefix, you can find this as your suffix also. A can be treated as one of the prefix suffix, okay, and the length of this is going to be 1. But can we find more such prefix which is also a suffix in this string of length more than 1? Let's concatenate these two characters, the first two characters. So if this is acting as your prefix, I need to get the same substring which is ending at n-1th index. So if I take the last two characters of my string, I can still get a, which is exactly equal to what is there in your prefix. So now the length is 2. Okay, this is greater than 1, so this can also be one of your longest prefix suffix. Okay, can I get a prefix which is also a suffix more than this length? Let's try and take this 3 characters of the string, the first 3 characters. In order to be a suffix, if this is your prefix, in order for this substring to be your suffix, you need to have the last 3 characters of your string to be AAA. So if I take last 3 characters, yes, I can find them as same as present in prefix of this string. So I can say the length is 3 and I can return it. Now you must be thinking, why cannot it be the entire string itself? In itself is also prefix and suffix, but no, then the question will not be anything. It will be, you can always return the entire string, means in such cases. So that's what not you want. Your suffix and prefix can be overlapping, but you cannot return that entire prefix which is entirely the suffix. You got this point? That means, for example, a b c b a b. For example, let's take this one. I have this character, okay, the first character I have taken, and the first occurrence of a in this entire string is at this position. Okay, they both are equal. How do we iterate now? Since they both are equal, let's go to the next index, this one, and to the next index after a, which is this. These both characters are also equal. Okay, good for me. I move to the next index here and move to the next index here. This becomes out of bounds. So basically I found a substring which is in prefix also and in suffix also. But the point is, can I get more than this, the length which is more than this? For that only we are going to understand how do we solve this problem. You got this point? Okay, so let's try and understand through this example, which you will, this question is not too tough. So basically there is this algorithm KMP, Knuth Morris Pratt algorithm, which is mostly used, which is the algorithm you use mostly for pattern searching. This is a pattern searching algorithm. The idea behind this algorithm is that you use an array, let's say LPS, longest prefix suffix array, in which you try to store the length of the longest prefix suffix which you are finding so far, and that we do by using 2 pointers here. How do we do that? That we will discuss through this example, and you will understand how we are maintaining this LPS array and it is returning us the answers. Okay, so we have to do this problem in big O of n solution. The brute force approach can be, we start from the, for all the substrings we iterate, okay, and we check for each substring in the prefix if I have the same substring in my suffix as well. So that thing can be done in O(n) square, very basic thing that you all know. I mostly discuss in every problem, which I don't want to take now. So let's move to the part where we will understand how can we solve or discuss this problem. Let's see. Okay, moving on. So let's start with, I'll give you a hint. We use 2 pointers here. Now how can you use those 2 pointers? Let's say I take an I take a j. Now how can you utilize these pointers to get your LPS array? Now don't get scared of this matrix that I have drawn. Don't take it as a matrix. To just minimize the, or for the ease of drawing, I have made it like this. Basically you are given a string, this one. Here I have written the indexes. Just do not relate it with that you are going to create an array like this. Not at all. Okay, you're not going to create an array or a matrix like this. It's not a matrix that you're going to create. It's just the representation I have used here only for the sake of representation. Okay, not that you're going to create this array in your solution. Okay, just for the sake of representation I have used it. What I want to represent, that the string over which we are going to discuss as a test case, then the indexes of these strings and the LPS array. So LPS array is one that I have taken of length exactly equal to the length of your string, new int whatsoever. Okay, now how are we going to do? So you compare what is your first character of the string. What is the first character of your string? You see it's right now. Let me put my I here, and let me take my I pointer at 0th index, and let me take my j pointer at first index. Okay, fine. What I want to do is, I want such a substring which starts at I. Let's say there is some substring starting at ith index, and there is some substring which is starting at jth index, right? And it should be ending at n-1th index. So what I want is, are these two strings equal to each other? If that is the case, then somehow LPS is made sure to store the answer so that we can get the maximum length. It will be storing the max length of such a prefix suffix. So let's iterate over it. What is the character at I and what is the character at j? A and C, are they equal? No. So you increment the count of j. Now your j is here. Is character at I index equal to character at j index? No. Move ahead. Not equal. Move ahead. Not equal. Not equal. Now you are at this position. So this is the first time that the str of I is equal to str of j. Okay. Character present at ith index is equal to character present at jth index. That means that there is a possibility to find a prefix which is equal to suffix. But is it actually, I found this first occurrence of A, but is it going to form a prefix which is also a suffix in this string? That we need to take a call after we iterate over it. Okay, so since we got these two characters equal, now my next step would be, you increment the count of I. Let's compare the next character in that row of strings and increment the count of j, so that we can know how long this prefix can go to form the equivalent suffix in the string. Okay, now the next character I am present at is this index, and this character is C. So both are definitely not equal. So what will you do in this case? What you will do in this case, you will ask, your LPS is made to store what is the length of longest prefix till that index, prefix suffix till that index. So initially your LPS is stored with 0 everywhere, whenever you found a match, whenever you found stri equal to str of j, what are you going to do? See your LPS of j. So you found this to be equal at this index, which is your fifth index. So this is where you will increment the count by 1. It was initially 0. You made it 1, which tells you that this is the length 1 which you found to be equal at this index. Okay. So this tells you, if you compare it with 0th index, at 5th index you have an occurrence which is exactly equal to this character, and this represents the length of that. So what is LPS doing? If you assume A, C, 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 B, A as your string, so LPS is storing what? It is telling you that if you check, any suffix would end at n-1th index only. So if this is your entire string, what is the maximum length of the prefix suffix? So this character is found to be equal with this character. So I incremented what was initial length 0. I incremented the count by 1. So this is just not what I am doing here. I am simply doing what is your ith value, ith index. I was 0, so I added 1 to it, which tells me that till this index my prefix is coming out to be equal to suffix. So this A was equal to this A. Now this A was at present at index 0 and this A is present at index 5. So LPS will store that at index 5 I have a suffix which is equal to the prefix, but the length of it is, what will be the length? That I index plus 1, right? So you are storing LPS of I whenever there is a match, whenever if this is the case, then what you are doing? You are storing LPS of j, right? This is 5th index and this is equal to I plus 1, which tells you that till that, if you consider this as your entire string, and j as the last index of that string, so this will tell you that what is the length of the longest prefix suffix. That's what it is telling you. Since it was a match with I at index equal to 0, so the length that you will store will be I plus 1, right? Okay, let's go ahead. Now your j is at this index, I is at this index. So it's not a match. So what would you do? In that case, since it's not a match and your I is also not at 0th index, now you will move your I to that index where the last prefix suffix was found to be. You got this thing? That means you will ask your LPS of j minus 1. Ask if this is the case, you are doing so. In the else case, what you are doing? If your I is not equal to 0, which was the case in this, then you are asking what is your LPS of j minus 1, right? So you move your I to that index. You move your I to LPS of j minus 1. Why? I'll tell you why. So LPS of j minus 1, j was at 6th index. Now you ask your LPS of j minus 1, which is 5th index. LPS of 5 till now would be 0 only. You know that. This is 0, 0, 0. Everything is 0 till now until we have filled it. So this tells you what is the length of longest prefix suffix which is ending at index 4. It tells you it is 0. That means there is no longest prefix suffix so far. It tells you length 0. So you should compare, again start your comparison with I pointing to LPS of j minus 1, which simply means, LPS of, one second. Of I should be equal to LPS of I minus 1. Reason being, your I is at this index, it's a non-zero. So that means there is a mismatch at I equal to 1 and j equal to 6. When we found a mismatch and I is not equal to 0, that means the previous index was a match, right? So what is that index? That is 0, right? So you will move your I to LPS of I minus 1 so that you can start over your comparison. And let's suppose this I minus 1, right now it is 0. If it was a non-zero value, how it would have helped you? It would have helped you by not considering the cases which are already added into your answer as longest prefix suffix. So it will help you in that way, reduce your search. Okay. So you move your I to I minus 1, which is 0 in this case. Okay. Now, right now my I is at what index? It is at 0 again and j is at 6th index. Let's check again. Now j is at 6. Let's do it again. So j is I is 0 this is I, and j is at 6th index. J is this. Now you tell me, is this a match? Yes, it's a match. If it's a match, so in LPS of 6, you will add what? I plus 1. The reason is that it's a match with I, so the length of longest prefix suffix would be this index plus 1, because that gives you length. So this will be stored with 1. Okay, so 6 is also 1. When it's a match, you move your I and simultaneously move your j. Now you again check, is this a match? Is this a match? Let me check if my test case is A triple C, B triple A triple C. Okay, fine. So we are at this position. Is this a match? No, it's not a match. Again, what you do? Your I will move to LPS of I minus 1. What is I in this case? It's 1. What is I minus 1? It's 0. What is LPS of 0? That shows you till 0th index. What is the length of longest prefix suffix? It's 0 so far. Again, you move your I back to I equal to 0. Okay, fine. Your j is still at this position. Is it a match? Yes, it's a match. So at 7th index of LPS, you will tell that you have found a prefix suffix if we assume that this is the entire length of your string. So in that case, what is the length? Since it's a match, you just simply do what is your I, that is 0 plus 1. Fine. That's what you're doing. LPS of j equal to I plus 1. Okay, move your I pointer here, your j pointer next. Is it a match? Yes, it's a match. So C is equal to C. What do you do when it's a match? LPS of j equal to I plus 1. I is at which index? 1 index. So 1 plus 1 will be 2. Move your I, move your j. I comes here, j comes here. It's a match again. What is LPS of I? It's 2. So 2 plus 1 is 3. So what it is telling you, that if you consider a string which is entirely till here, if this was your entire string, that is the last index is 9. In that case, the length of longest prefix suffix is coming out to be 3, which if you can observe also, if you check, if you observe this in this way, ACC is equal to ACC. This is the last of this string. So it keeps a track, LPS is keeping a track, that if you consider the string to be ending at this index, then what is the maximum length of a suffix that is equal to its prefix, right? That's what it is giving you. And this we are extending for the entire string. That's what we are doing. Okay, let's move ahead. Now you found a match. Move your I, move your j. One step ahead. J is here. Again, it's a match. So why am I doing I plus 1? I hope you have understood. The reason is I am incrementing the count of I and j only when I am incrementing only when I find it is a match with character at j. So I is storing some index, means I some index, so that index plus 1 will tell me the length of that prefix which is equal to the suffix. Okay, so that is why in LPS of j I am storing I plus 1. Now move your I, move your j. It's a match again. I equal to j, b equal to b, means character at I is equal to character at j. So what is index I? It is 4. 4 plus 1 is 5. This is the entire length. So you can verify also A, C, 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 B. A, C, 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 B. Fine. Okay. Next character is for j is A. Next character for I is also A. Both are equal. So LPS of 12. This index will be I plus 1, which is 6. Okay. Move ahead. J is at this position. I is at this position. Okay. Fine. So again they both are equal. So LPS of this character will be I plus 1, which is 7. This will become 7. Okay. Move your I to the next index. Move your j to the next index. Now wait, there is a mismatch. There is a mismatch. Now you have moved to the end of your string, but there is a mismatch. A is not equal to C. So what are you going to do in this case? You will ask your, since at this position it's a mismatch, so definitely one position back, one position behind must have been a match. Only then I moved my I. So when there is a mismatch and your I is not equal to 0, what do? You move your position of I, you move your I back to what? LPS of I minus 1. So what is LPS of I minus 1? Currently I is at 7. I minus 1 is 6. So this is telling you till this string, the maximum length of longest prefix suffix was found to be 1, which means if you consider one length of your prefix, one length of a substring which is present in the starting of your string, that is found to be the length of the maximum length of prefix which is acting as suffix so far. So you move your I to that index. Okay, so LPS of I minus 1, I was what? 7, I minus 1 would be 6. So LPS of 6 is 1, which is telling you that till index 0, it is the length, right? So index wise it will be 0. So till index 0 it was a match. So better move your I to next position, which is your LPS of I minus 1, that is 1. So now you make a match, try to make a match with this. So why did I do so? So whenever there is a mismatch and I is not equal to 0, I am asking my I to go at LPS of I minus 1. Why? Because I am assuming that LPS of I minus 1 is storing the length of maximum length of longest prefix which is also a suffix. So if I know the length, I can definitely move to, because till then, that clearly means if I have stored some non-zero value here, that means there was a prefix which was acting as a suffix. So why to again iterate over it and add to and ask my answer? I will go back to A, ask my J if it was equal. So it says no, it was not equal. Then you will move your I to the next pointer. Then you will find a match and you will say. Why to do the things repeatedly? Rather move your I to LPS of I minus 1, which will tell you that this is the next character which you should probably try to match, and if you found that match, then it can be one of your length of longest prefix suffix. Okay, so I moved my I here and my J is at this position. They are a match. So first of all, I will make my LPS of J equal to I plus 1. So I is at 1 index, so LPS of J, LPS of 14 will become 1 plus 1, which is 2, which simply tells me that at this position, what you found the length 2 as the length of the longest prefix suffix. Now you move your I to the next index and J to the next index. Since your J has gone out of bounds, that means your LPS of n minus 1 might have some value. If whatever value is that, you will return, because what is LPS supposed to store? At any index, LPS is storing max whatever is the answer. It can also be understood as a DP, in which not exactly, but what is the purpose of creating a DP array? We try to get the answer from the previous evaluated answers, right? So that's what we are doing for every LPS index. At every index in LPS, it is storing what if this was that index starting from 0 till that I was the entire string. So for that entire string, it will store the maximum length of a prefix suffix, max prefix, which is also a suffix. And you are doing this thing for until your I becomes equal to n minus 1 index. So n minus 1 index will be storing, if this is your entire string starting from 0 to n minus 1, what is the maximum length of that string in that case. So what it is returning? It is returning you 2. So if you see AC, this AC, let me show you, this AC is equal to this AC. So this is the maximum length of substring which is acting as a prefix as well as a suffix. You got this? So that is all about this problem. Let's move to the code and solve it. So what we are taking here is that we are taking int LPS equal to new int of length n. Let me create n as equal to s dot length, correct? Okay, this is of length n. Then you are taking two indexes. I told you one is starting at 0, another one is starting at 1 at the index. Okay, int j equal to 1. So while you are keeping a track at j, while j is less than n, you are checking if s dot char at I equal to s dot char at j, correct? If they both are equal, what do? You move I as well as you move j, and before doing that, you store in LPS, your LPS of I is equal to your LPS of j, right? We are doing it for suffix part. LPS of j will be equal to I plus 1, correct? Otherwise, first of all, you will check if your I is not equal to 0. Right, because if it is equal to 0, just increment the count of j, do nothing with I. So I in that case will become LPS of what? I minus 1, as I explained to you. This is what we were doing, LPS of I minus 1, right? This part. If I is not equal to 0. And if I is already at 0, then you just need to do I plus plus, that's all. Sorry, if I is already at 0 and there is a mismatch, you cannot do anything. You have to start your prefix from I equal to 0 on it, and it is already at 0. Simply increment the count of j, like we were doing here. You started your j from this index, it was a mismatch with this index, so you moved your j here. Then it was a mismatch again, you moved your j here, it was a mismatch again, you moved your j here, mismatch, you moved your j here, it was a match, and then you were incrementing I and j and filling up the LPS array, correct? And once you have done this also in else part, what do? You move your j plus plus, and finally when you come out of loop, you return LPS of n minus 1th index value. Let's check. So what is the time complexity? As I showed you, the maximum is our iteration is dependent upon j, it is moving ahead of I. Maximum is big O of n time complexity, and since we are taking an LPS array exactly of length equal to string length, so space complexity is also big O of n, not big O, it's also of n, the space complexity. That is all about this problem. So if you guys have any doubts, you can ask me. You can see it here, the pseudocode, and let me move back to this code. So that was all for today. Okay, then no doubts, let's wrap it up. Thank you everyone. See you in next lecture. Bye bye.